Okay, Bismillahirrahmanirrahim. We finished now all the exams questions. Now we'll do questions from the book. Problems 1 through 28. Let me try to do it. He said, what determine whether or not the given matrix is diagonalizable? If it is, find the diagonal matrix, diagonalization matrix P, and the diagonal matrix D. Okay. So very clear. I'll find eigenvalues, eigenvectors. So A minus lambda I. That give me what? 5 minus lambda minus 4, 2 minus 1 minus lambda. I'm getting what? Lambda square, lambda minus 5, lambda minus 4, lambda minus 5 plus 8 equal lambda square minus 4 lambda plus 3, which is lambda minus 3, lambda minus 1 equal 0. So lambda equal 1 and lambda 2 equals 3. Yeah, for sure it's diagonalizable. Okay, distinct and real diagonalizable matrix. So let me find the eigenvectors. Lambda 1 equal 1. Let V1 K1 K2. I'm getting what? 4 minus 4, 2 minus 2. I have what? 4K1 minus 4K2 equals 0. And 2K1 minus 2K2 equals 0. So I'm getting K1 equal K2, very clear. So let K2 equal 1. K1 will be 1. So my V will be 1, 1. V1 will be 1, 1. Now for lambda, 2 equals what? 3. I let V2 to be K1, K2. So I have the system 2 minus 4, 2 minus 4. Times K1, K2 equals 0, 0. So I have only one equation. Very clear. So I have K1 equal to K2. So let K2 equal 1. I'm getting K1 equal to. So V2 will be 2, 1. So what is D? 1, 0, 0, 3. And P 1, 1, 2, 1. Good. Yeah. Another example. I have A minus lambda I. That will be what? 6 minus lambda minus 6, 4 minus 4 minus lambda. That'll give me what? Lambda square. Or lambda minus 6 lambda minus 2 lambda. Okay. Minus 24 plus 24. That equal to lambda times lambda minus 2. This is cancelled. Equal 0. So I have lambda equal 0. Or lambda 2 equal 2. Okay. So it's for sure it's diagonalizable. The matrix is diagonalizable. Since I have real and distinct, I have distinct eigenvalues. So for lambda 1 equals 0, I let V1, K1, K2, solve the system, minus 0, so it's nothing. So I have what? 6K1 minus 6K2 equals 0. 4K1 minus 4K2 equals 0. Very clear, I have K1 equal K2. So let K2 equal 1. I'm getting K1 equal 1. So V1 will be 1, 1. Yeah. Now for lambda 2 equals 2. I did V2 now to be K1, K2. So I have the system. 6, what is the lambda 2? 2. It will be 4 minus 6. 4 minus 6 K1, K2. So I'm getting 4 K1 minus 6 K2 equals 0. So I'm getting K1 equals 3 over 2 K2. So I let K2 equal 2. K1 will be 3. So V2 will be 3 and 2. D 0, 2, 0, 0, and B 1, 1, 3, 2. Good. Let's do the next one. 9. Okay. We'll find A minus lambda I minus 1 minus lambda 4 minus 1, 3 minus lambda. I'm getting about lambda square minus 3 lambda plus lambda minus 2 lambda minus 3 plus 4. That give me lambda square minus 2 lambda plus 1, which is lambda minus. It's diagonalizable or not. I need to check. I get how many eigenvectors since it's repeated. For lambda equal 1, what I have? I let V1 equal K1, K2. What will be the system? Minus 2, 4, minus 1, 3 minus 4 minus 1 is 3. 3 minus 1 is 2. Times K1, K2 equals 0, 0. These two equations are the same. Minus 2K1 plus 4K2. Yeah, these two equations are the same. Multiply 2 by the second one, I get the first one. So I have K1 equal to K2. So I let K2 to be equal to 1. So K1 equal to, so I have only one eigenvector, which is 1 and 2. Only one eigenvector. That means A is not diagonalizable. Yeah. Then do the same. A minus lambda I. I have 3 minus lambda minus 1. 1, 1 minus lambda. That gives me what? Lambda square minus 4 lambda minus lambda minus lambda minus 4 lambda plus 3 plus 1. That will be lambda square minus 4 lambda plus 4, which is lambda minus 2 square. So lambda will be 2, 2. Now for lambda equal to, let V1, K1, K2. What will be the system? 1 minus 1, 1 minus 1. So I have what? K1 minus K2 equals 0, which means K1 equal K2. I did K2 equal 1, so K1 equal 1. So my V is 1, 1. I have only one eigenvector. I have only one eigenvector. So A is not diagonalizable. Okay. Now we'll go to 3 by 3. Now the calculation becomes a little bit complicated. Let me see what will happen. I have do the same. That will be 1 minus lambda 3, 0. Many zeros that good. 0, 0, 2 minus lambda. That will be what? 1 minus lambda 2 minus lambda all square equals 0. So lambda equal what? 1, 2, 2. So for lambda equal 1, let V1, K1, K2, K3. Let me see what will happen. I have 0, 3, 0, 0, 1, 0, and 0, 0, 1. 0, 0, 0. Okay. So I have what? Times K1, K2, K3 equals 0, 0, 0. So I have 3K2 equals 0, and K2 equals 0, and K3 equals 0. This implies K2 equals 0, and here I have K3 equals 0. So K1 is free. There's no restriction on K1. So let K1 equal to 1. So it will be V1, 1, 0, 0. Okay. Now for lambda equal to, let V2, K1, K2, K3, solve the system. That will be minus 1, 3, 0, 0, 0, 0, 0, 0, 0. We have what? You have minus K1 plus 3K2 equals 0. So K1 equal 3K2. K1 equals 3K2. That means what? That means K2, also there's no restriction in K3, and K3 are free variables. So do restrict K2 equal 1, K3 equal 0. To have linear independent, K2 equal 0, and K3 equal 1. So it will be K1, it will be 3 in this case, and it will be 0 in this case. So you have V1, V2 actually mean, V2 will be 1. This is 0, 1, 3. K2, K3 is 0, and K2 equal 1, and K1 equal 3. So that will be 3, 1, 0. And V3 will be 0, 0, 1. So it will be D, so it's diagonalizable. Why? Since I have 3 eigenvectors. D will be what? 1, 2, 2, 3 star zeros. And E. Same order. 1, 0, 0, 3, 1, 0, 0, 0, 1. That will be B. Wait a minute. Yeah, I'm starting with this. Yeah, it will be okay. Next one. We need determined A minus lambda I. See what will happen. Okay. So I have 3 minus lambda minus 3, 1, 2, minus 2 minus lambda 1, 0, 0, 1 minus lambda. We'll do the expansion with the last column, with the last row, I mean. They have what? 3 minus lambda minus 3, 2, minus 2 minus lambda. That give me 1 minus lambda. I have lambda square. 2 lambda minus 3 lambda, that is minus lambda. Minus 6 plus 6, that will be 0. Yeah. So it will be lambda 1 minus lambda 1 minus lambda. Is it? Lambda minus this one equals 0. So lambda will be 0, 1, 1. I don't know exactly or not. I need to check. No, for lambda equals 0, I let V1, K1, K2, K3. What I have is 0, it's easy. It will be the same matrix. So I have, what are the equations? 3K1 minus 3K2 plus K3 equals 0. 2K1 minus 2K2 plus K3 equals 0, and I have K3 equals 0. So this is 0. So I have from here K1 equal K2. So let K2 equal 1. I'm getting K1 equal 1. So my V1 will be 110. lambda equals 1. I need to do 1 lambda equals what? 1. I need V2 to be K1, K2, K3. See what will happen. I have 2 minus 3, 1, 2 minus 3, 1, and 0, 0, 0. So I have 2K1 minus 2K2 plus K3 equals 0. So it means K3 equals 3K2 minus 2K1. Sorry. Is it? Yeah. So I have K1 and K2 are free variables. So I let K1 to be 1 and K2 0, and K1 equals 0, and K2 equal 1. What will be K3 in this case? K3 will be minus 2, and in this case K3 will be 3. So I have V2 will be 1, 0 minus 2. This is K2. And V3 will be 0, 1, 3. 3, 2, 0. Yeah, okay. So diagonalizable, I have 3 eigenvectors. So what is D? D will be 0, 1, 1. And P will be what? 1, 1, 0, 1, 0, minus 2, 0, 1, 3. There are many solutions, but this is one of them. Okay. 18. Let me find A minus lambda I. That will be what? 2 minus lambda minus 2, 1, 6 minus 5 minus lambda 2, 6 minus 3, 1 minus lambda. Let me make this 0. Multiply the second row by minus 1 and add it to the third row. You will get what? 2 minus lambda minus 2, 1. Yeah, but this is the same. 2. That will be 0. Divide by minus and add it. That will be lambda minus 2. Divide by minus and add it. That will be 3 minus lambda. Okay. Now let me do the expansion. 2 minus lambda. Be careful now. Minus 6. Cancel this with this. It's 2, 1. See what will happen. I have 2 minus lambda. What is this? Here I have lambda square. Okay. Minus 3 lambda plus 5 lambda. Plus 2 lambda. Minus 15. Plus 2 lambda. Minus 2 lambda, sorry. Minus 2 lambda. Plus 4. Okay. And in this one, I have minus 6 times I have 2 lambda minus 6 minus lambda plus 2. So you have what? 2 minus lambda. This is cancelled. I have lambda square minus 11 minus 6. This is lambda minus 4. Yeah, it seems to be too complicated. So what I'm getting? Minus lambda cubed plus 2 lambda square plus 11 lambda minus 22 minus 6 lambda plus 24. That will be what? Minus lambda cubed plus 2 lambda square minus 5 lambda plus 2. If lambda is 1, I'm getting 0. No. I did a mistake somewhere. How to figure it out? No. Lambda should be 1, is one of the answers. You have minus 1 plus 5. No. Okay. I did a mistake somewhere. Calculation mistake. Okay. Multiply by minus 1 and add. That will be 5 plus lambda. That means lambda. That should be plus 2. This should be plus 2. Yeah. So this should be plus 2. This should be plus 2. I cancel this and this. I have this is plus 2. And that will make what? This is minus 4. And this is minus 2. So this is minus 19. And this is minus 8. This is cancelled. See what will happen. I'm getting the correct answer or not. That give me minus lambda cubed. Square will be what? 9 lambda. 2 lambda square. That will be 2 lambda square. Nothing is there. Plus 19 lambda. Minus 38. Okay. Minus 6 lambda. Plus 48. Is that minus lambda cubed? Plus 2 lambda square. 19 lambda minus 6 lambda. Plus 15 lambda. Plus 10. It's worse. Stacking it from the beginning. Yeah, multiply by minus and add it. That will be lambda plus 5 minus lambda plus 2. By minus and add it. That will be. Yeah, this is wrong also. All of this wrong. Sorry for that, yeah. Multiply by minus and add it. That will be minus 1 minus lambda. Minus 2 minus 1 minus lambda. Okay. So let me try the last time. The 2 minus lambda is minus 5 minus lambda 2. 2 plus lambda minus 1 minus lambda minus 6. I cancel this with this. Minus 2, 1 lambda plus 2 minus 1 minus lambda. This is 2 minus lambda times what? This is lambda square. Lambda plus 5 lambda plus 6 lambda plus 5 minus 4 minus 2 lambda. Okay, minus 6. This will be what? 2 plus 2 lambda minus lambda minus 2. Inshallah better. Okay, 2 minus lambda. This is what? I have lambda square plus 4 lambda. Okay, plus 1 minus 6 times lambda. Seems to be correct now. So I have what? Minus lambda cubed minus lambda cubed 2 lambda square minus 4 lambda square, that 2 minus 2 lambda square minus lambda plus 8 lambda plus 7 lambda plus 2 minus 6 lambda. That will be minus lambda cubed minus 2 lambda square plus lambda minus 2. Okay, plus lambda plus 2. Perfect. This I can take minus lambda square common factor. I have lambda plus 2 plus lambda plus 2. That gives me lambda plus 2 times 1 minus lambda square. What is lambda plus 2? 1 minus lambda 1 plus lambda. Wow. So lambda will be minus 1, 1, and 2. What a calculation. Okay. So now for lambda 1 equal minus 1. Let me see what will happen. I let V1, K1, K2, K3. So I have what? 3 minus 2, 1, 6. Minus 5 minus 1, that will be 4, 2. 6 minus 3. 1 minus 1, that will be 2. Times K1, K2, K3 equals 0, 0, 0. And solve these three equations. Which is not easy to do. Okay. I notice these two equations. If I subtract them, I get what? These two equations only. I have to get 7K2 equals 0. So K2 equals 0. Good. I get rid of this. So I have 3K1 plus K3 equals 0. And 6K1 plus 2K3 equals 0. They are the same. So I can say K3 is minus 3K1. So I let K1 to be 1. K3 will be minus 3. So V1 will be what? 1, 0, minus 3. Good. Now we'll come to the next one. I have for lambda equal 1. Let me write the matrix here. No need to go back and forth. 2 minus 2. 1. 6 minus 5, 2. It's calculation, nothing is there. Just I'm repeating the things. 6 minus 3 and 1. Now I have lambdas. What are the lambdas remaining? 1. Lambda equal 1. Let V2, K1, K2, K3. See what will happen. I have what? 1 minus 2, 1. I have 6 minus 5 minus 1. That is minus 6, 2. 6 minus 3, 0. I think easy to do Gaussian elimination in this case. So Gaussian elimination, since the starting point is 1. So multiply by -6. See what will happen. I have this is 0 by -6 and add. That will be 6 by -6 and add. That will be -4. Okay, by -6 and add, that will be 0. By -6, 12 minus 3, that will be 9. -6 and add, that will be -6. Okay. Yeah. Now, no, it's still complicated. Let me take these two. I have 6k1 minus 4k, 6k2 minus 4k3 equals 0. 9k2 minus 6k3 equals 0. I think it's easy to solve these ones. Multiply by -3, the first one, and by 2, the second one. You have what? Minus 18k2 plus 12k3 equals 0. And I have what? 18k2 minus 12k3 equals 0. So I'm getting 0, 0. So these two equations are the same. Okay. So no need to do anything. I have just, I can write k2 is 2 over 3k3. Okay. Substitute in 1. So I have k1 minus 2k2 plus k3 equals 0. So that means k1 will be minus k3 plus 2k2. What is 2k3? That will be minus k3, 2k2. 2k2 plus 4 over 3 k3. That give me what? 1 over 3 k3. So I let k3 is my free variable. So k3 equal 1 equal 3. That implies k2 equal 2, k1 equal 1. So my v is 1, 2, 3. Good. Now for lambda equals -2. Was it -2? Plus 1, 2. 2 or -2? It is -2, sorry. For lambda equals -2. I should start with this one. Okay. What I have, I let v3, k1, k2, k3. By the way, the suggested problems already will not solve it. 2 minus, so that will be 4 minus 2, 1. 6 minus 3, 2. 6 minus 3. 1 minus, that will be 3. Times k1, k2, k3 equals 0, 0, 0. So I need to solve these three equations. Find the best way to do it. I have 6k1. I think I'll do the same trick we did in the first case. If I take these two, subtract them, I'm getting minus k3 equals 0, so k3 equals 0. Plug it, I have what? 4k1 bigger than the first one. I have 4k1 minus 2k2 equals 0, or 6k1 minus 3k2 equals 0. Both they are the same. So it means k1 equal, or k2 equal 2k1. Yeah. If k2 equal 2k1, that we have everything 0, 0. Okay. So let k1 equal 1. that implies K2 equal 2. So V3 will be 1, 2, 0. So it's diagonalizable, for sure. Actually, from here, since I have distinct, so diagonalizable matrix. No need to wait until the end. So what will be D? D will be, I have -1, 1, -2. I did it this way. And what is B? I need the same order. The first V1 is 1, 0, -3. Lambda equal 1, I have 1, 2, 3. And this one, 1, 2, 0. You need to do it the same order. Like the diagonal matrix. Okay. Let me do the next one, 21. Hopefully it will be easier. I have A minus lambda I. That give me what? Minus lambda 1, 0, -4, 4 minus lambda 0, -2, 1, 2 minus lambda. Okay. You know what? I can multiply this. Oh, I have this one. I can do the expansion with the last column better. That will be 2 minus lambda. Cancel this with this. Minus lambda 1, -4, 4 minus lambda. Yeah, that will make it easier. So you have lambda square minus 4 lambda plus 4. Nice. That will be 2 minus lambda. Lambda minus 2 square. So I have minus lambda minus 2 cubed. So lambda is 2 multiplicity 3. That's good. For lambda equal to, I let V1 see how many eigenvectors I can get. I need to get 3 eigenvectors or it will be not diagonalizable. What will be the system? It will be -2, 1, 0, -4, 2, 0, -2, 1, 0 times K1, K2, K3 equals 0, 0, 0. So what I have, -2 K1 plus K2 equals 0, -4 K1 plus 2 K2 equals 0, -2 K1 plus K2 equals 0. These are actually, they are only one equation, which is K2 equal to K1. So what are the free variables? Are K1 and K3, because there's no restriction in K3. So I let K1 equal 1 and K3 equal 0 and K1 equal 0 and K3 equal 1. What will be K2? It will be 2, and here it will be 0 because it depends on K1 only. So it is my V1 1, 2, 0, and V2 it will be 0, 0, 1. So how many vectors I have? I have only two eigenvectors. I have only 2 eigenvectors, but actually I need 3. So A is not diagonalizable.